Welcome back everyone, Patrick here, and moving on to the next factoring video. So we have to factor each of these expressions here if it is possible. And notice that these are more complex expressions that we're going to be factoring here compared to the previous videos, because in all of these there's actually going to be greatest common factors that we could take out. So in the previous video sometimes there were greatest common factors, sometimes there weren't. In this video all of these are going to have greatest common factors that we have to initially take out, and then the remaining portion we're going to be factoring by decomposition. So when I'm doing this video, I'm assuming you've watched the previous videos, that you're following an order on the website. If you're watching this on YouTube, you can go to the website, the link is in the description box. You can follow the videos in order and make sure you do so, because again, lots of carryover is happening as we progress through the chapter. So let's start off with part A. We got 5x squared plus 15x plus 10 over here. So as usual, first thing we check for, can we take something out? Notice in this case we got a 5, 15, and a 10. We could take out a 5 from all of these. So when we take out a 5, what would we be left with in the bracket? Well, we could just take everything and divide it by 5. So we'd be left with the 5's cancel out here. We'd be left with an x squared plus 3x plus 2, like that. Right? And then you can always check. You could redistribute the 5 in the bracket. Make sure you get that initial expression. So from here, notice in this bracket, nothing else we could take out. So let's actually just work with that quadratic itself right here. And then we'll come back to this main work up here. So let's factor this. So let's go into the decomposition. So what do we do? First step, write out the A, B, and then the C value. Next step, what you want to do is you want to multiply the A and the C value, which is going to be 2 times 1, which is 2 in this case. And then you want to find two numbers that multiply to this AC value of 2, and then add up to this B value of 3. Now, because this A value is 1, right, this AC value, whenever the A value is 1, it's always going to equal the C value. But when the A value is not 1, which is quadratics we're going to work with in the future, this AC value is not always going to equal that C value. So that's why I'm taking this extra step. It seems kind of redundant to do so at this point, because you could just take this 2 and put it here. But I'm just trying to build the habits for you in order to be prepared once we are dealing with more complex quadratics where that A value is not going to be 1. Right, so from here we got to find two numbers that multiply to 2, add up to 3. So that would be what? 2 and 1. Right, 2 times 1 is 2, 2 plus 1 is 3. Again, because we're dealing with an A value of 1, we know that the final answer is just going to be these two numbers here. So we could put x plus 2, x plus 1. So that's what it's ultimately going to factor to. This is going to equal that. But again, that only works, this shortcut only works if that A value is 1. I mentioned this a bunch of times in previous videos. If that A value is not going to be 1, you're going to see in future videos that you're not just going to be able to go from here to here. Right? You're going to have to do the whole process. And the way you do the whole process, I'm going to be doing the whole process for all of these, is you decompose that middle term into those two values that you got. So it was 2 and 1, like that. So then you factor by grouping. So from these two, notice we could take out an x, so we'd be left with x plus 2. Then from here we have a 1x plus 2. Whenever you have a 1x over here, you always just take out a plus 1, like that. And you'd just be left with x plus 2. Same thing if you have like a minus 1 over here, you would just take out a minus 1, and then all of the signs would change here. And sometimes it doesn't even have to be just 1 here for you to take out a 1. So let's say this was like, sorry, I'm kind of going off on a tangent here. But let's say we had like 3x plus 5 over here. Notice that we can't factor anything out of the 3 and the 5. So in this case as well, you would just factor out a 1, right? I think we've done examples like that in the previous videos as well. Okay, so it doesn't just have to be 1 over here every time for you to just factor out a 1. All right, so Just be on the lookout for that. But in this case, it was clearly a 1 here, so we just take out that positive 1, and then we're just left with that same expression, x plus 2. And the reason why is because now we got these two brackets. We could take out that x plus 2. What are we left with? We're left with x plus 1. Exactly what we were aiming to get or expecting to get. So the final answer, now this bracket here, right, this expression, it factors into these two, but then we still have that 5 in front, so don't forget that when you're writing your final answer. And then if you want to check your answer, if this is on a test, what you could do is you could just expand everything, make sure you get that initial expression. Right, so that's the answer for part A. Part B, what do we got here? We have negative x squared plus 13x minus 40. So in this particular case, notice we have a negative here. Whenever I have a negative value for the leading coefficient, whether it's -1, like in this case, or it could be -2, -3, I always take out at least a -1. Right? And over here in this particular case, we could only take out a -1. I always like to work with quadratics where that leading coefficient is going to be positive. So we have a -1 in front here, so we'll definitely take that out. And then what's going to happen, everything's going to stay the same, but all the signs are just going to change because we're dividing everything by -1. So we'd have x squared minus 13x plus 40, like that. Again, if you take that -1, redistribute it in the bracket, you'd end up with that original expression. Okay, so now what we can do is we could work with this quadratic separately, and then we'll come back and put that -1 in front after we factor this. So same steps, A is 1, B is -13, the C value is positive 40, A times C is 40. So we've got to find two numbers that multiply to that AC value of 40, add up to that B value of -13. Like that. And then if you do some trial and error, the two numbers, the two integers, are going to be -8 and -5. Right? -8 times -5 is 40. -8 plus -5, this plus and minus turn into a minus, so -8 minus 5 gives us -13. Right? So those are the two values here. Now we know because the A value is 1, as a shortcut, our final answer is going to be x minus 8, x minus 5. It's just going to be those two values there. But let's go through the whole process of decomposing that middle term into those two terms. Like that. So here from these two we could take out an x. We got x minus 8. Then from these two, we got -5x plus 40. Whenever this is negative, we always take out a negative value, at least a -1, but in this case, we could also take out a 5. And so we'd be left with x minus 8, right? Positive 40 divided by -5 that you took out gives us that -8. And then, as usual, these brackets should always be the same in your decomposition process. That's a nice check within the process that you're doing it correctly. So let's take out that x minus 8 now from both of these, right? Factoring out that binomial common factor, and we're left with x minus 5, just as we expected. Now remember, this is these two brackets, but then we still got that negative in front. So the final answer is going to be -1 x minus 8 x minus 5. Now moving on to part C, one thing I want to mention is that this here should be an 84. It was 120 written before, but that would have been a mistake. This here should be, the C value should be 84. So apologies for that. Hopefully you didn't try to factor that, or if you did try to factor it, you would notice that there was an issue and you couldn't factor it if it was 120. So it's actually supposed to be 84 here. So if we write this out like that, first thing we check for, greatest common factor. Notice 4, 40, and 84. We could take out a 4 from everything. So we'd end up with x squared plus 10x plus 21, like that. And then what we want to do, we want to take this remaining bracket and then factor it by decomposition. So the A value is 1, the B value is 10, the C value is 21. The AC value, 21 times 1 is 21. So then we got to find two numbers that multiply to 21, that AC value, add up to that B value of 10. Sorry, should be 10. And what are the two numbers going to be? It's going to be 7 and 3. 7 times 3 is 21. 7 plus 3 is 10. Because that A value is 1, we know that what we're aiming for is x plus 7, x plus 3. But let's do the full process, because we're not always going to have scenarios where that A value is going to be 1. So that shortcut's not always going to be available to us. So from here, decomposing that B term into those two values that we found, the 7 and the 3, we got 7x and 3x. Factor by grouping. From these two, we could take out an x. From these two, we could take out a 3. And then we could take out an x plus 7 from both of these, and we'd be left with an x plus 3, like that, just as expected. Remember, we got that 4 in front, so the final answer for this would be 4 bracket x plus 7, x plus 3, like that. Right, moving on to part D, we got negative 6x squared plus 12x plus 90, like that. So first off, notice the leading coefficient is negative, so we're definitely going to take out a negative value, at least a -1. But also notice we're working with a 6, 12, and 90, so common factor for all of those is 6. So we could actually take out a -6 for all of these. And so if we divide all these by -6, we'd have x squared minus 2x. 12x divided by -6 is minus 2x. 90 divided by -6 would give us minus 15. Like that. Okay, and then from here, we just factor this remaining quadratic. So A value is 1, the B value is -2, the C value is -15. The AC value is -15, so we've got to find two numbers that multiply to -15 and add up to that B value of -2. And so what two numbers would that be? I think -5 and +3 work, right? -5 times 3, -15, -5 plus 3 gives us that -2. Again, as usual, A value is 1, so we know our final factored form is just going to be those two values, x minus 5, x plus 3. But let's do the full process over here just to double check and just to practice for the next section when we're not going to have that nice A value of 1. So from here, factor by grouping, we could take out an x, so we'll be left with x minus 5. From these, we could take out a 3, x minus 5. As usual, as expected, these brackets should be the same, and what we're left with is an x plus 3. All right, so this expression factors into that. Don't forget the -6 in front, right? So this would be -6, x minus 5, x plus 3. So that ends up being the answer for part D. And then finally moving on to the last two. So notice these two, they're a little bit more complex because they're actually working with multiple variables in both of them, but they're still not too bad. If you've gone through all of the greatest common factoring videos before, then these should be fairly easy for you to factor. So let's start off with the first one. So let's first notice that in terms of numbers, can't take anything out because there's a 1 in front here, right? We've got a 1, 7, 44. That's not going to work out. But notice in all of these, we have this m variable that we could take out. So that's definitely going to go. And then also notice that in all of them, there's an x variable as well. And if you have the same variable in all of them with different exponents, you can always take out the one with the lowest exponent. So in this case, 3, 2, and 1, that's the lowest exponent right there. Right? So the greatest common factor for this is mx right here. Now to find out what we're left with, what I recommend doing is maybe on the side here, just because these are a little bit more complex, divide all of these by that greatest common factor that you're taking out right there. So here the m's cancel out, x to the 3 over x to the 1, subtract the exponents, we're left with x squared. These cancel out, x to the 2 over x to the 1 is just x to the 1. We got the 7 there as well. So we got 7x, then we got the minus. This cancel out, so we're just left with a 44, like that. Right, so greatest common factor in this case was the mx, took that out. Now we're left with this quadratic, and then that quadratic, let's factor with decomposition. So in this case, what's the a value? It's 1, the b value is 7, the c value is negative 44. So the AC value is negative 44, right? Negative 44 times 1. So then we're going to find two numbers that multiply to negative 44 and add up to that B value of 7. And when you do a little bit of trial and error with this, you would see it's what, 11 and 4, or rather positive 11 and negative 4. I think that works out. Right, let's double check. 11 times negative 4 is negative 44. 11 plus negative 4 is like 11 minus 4. The plus and minus turn into a negative. 11 minus 4 would give us 7. Right, so those are the two numbers. Because that a value is 1, we know our final answer is just going to be those two values, but let's do the full process of decomposing that middle term, that b value, and then factoring by grouping here. We could take out an x from the first two. From these, we could take out what? A negative 4, and we'd be left with x plus 11, right? This divided by negative 4 is just x. This divided by negative 4 is positive 11. And as expected, these brackets should always be the same. Take out that bracket, and we're left with x minus 4, like that, as expected. All right, so part E factors, the greatest common factor was mx, and then that remaining quadratic here we factored into those two brackets. So it would be x plus 11, x minus 4, like that. Okay, now part F, this is the toughest one. Still not too bad though. So first thing to realize is notice that this leading term here, it's negative. So we're definitely going to take out a negative value. And notice we got a 2, a 38, and then a 140. All of those are factors of 2. So we could definitely take out a negative 2. Let's look at the variables. We got x to the 4, x to the 3, x to the 2. So it contains an x in all the expressions. We could take out the one with the lowest exponent, which is x to the 2. And we got y to the 3, y to the 3, y to the 3. So we could just take out a y to the 3. That's common in all of them. Right? Now, what are we going to be left with? So because we're taking out a negative here, I'd recommend writing out the signs for all these expressions when you're going to divide by that greatest common factor, because basically all of the signs are going to change. Okay, when we just factored out that mx there, we didn't write out the signs because we knew the signs were going to be the same, so we just wrote out the signs while we went through them. And we just looked at these expressions separately without the signs in front of them. Because we're taking out a negative, I recommend putting all of the signs just so you don't forget to switch the signs. So we're taking out this from all these expressions. So divide this by that. Divide that by that greatest common factor, and then divide this by that greatest common factor. So here the negative 2's cancel out, the y to the 3's cancel out, and then we got x to the 4 over x to the 2, which just gives us x to the 2. Negative 38 divided by negative 2 would give us positive 19. Those go away. X to the 3 over x to the 2 is just x to the 1, so it's just x. And then y to the 3's cancel out. So we're left with a positive 19x here, positive 70. X to the 2 over x to the 2, those cancel. Y to the 3, y to the 3, those cancel as well. So we're just left with a positive 70 over here. So from here, all that's left to do is to factor that remaining quadratic. So let's actually write that quadratic out right here. And let's do decomposition. A value is 1, the B value is 19, the C value is 70. The AC value would be 70 times 1, which is 70. And then, got to find two numbers that multiply to 70, add up to that B value of 19. Okay, and if you work this through, try different ones like 10 and 7. 10 times 7 is 70, but 10 plus 7 is 17. It's not 19. What you would end up with is, I think, 14 and 5 work. Give me a sec here. Yes, 14 and 5 does work, right? 14 times 5 is 70. 14 plus 5 is 19. So from here, because the A value is 1, as a shortcut, we know that this is going to be the answer. But let's do the entire process. I've mentioned this in previous videos. It doesn't matter which order you put these here as well. So let's maybe just go with the 5x. Let's switch it up a bit. You should still get the same value when you do the factoring by grouping. So here, from these two, you can take out an x. From these two, we can take out a 14. And we're left with an x plus 5. Take out the x plus 5. And we're left with x plus 14 as expected. Okay, so this final one, it factors into, first we took out that greatest common factor. I feel like that was the trickiest part in this question because we should be fairly confident in factoring by decomposition over here. And then this one, we had to check if it factors. Also, another thing I want to mention, sometimes maybe these aren't going to be able to factor. In all of these examples, this remaining bracket was able to factor, but you might run into a scenario where maybe once you get to here, you won't be able to find numbers where this works out. And so this final bracket won't be able to factor. And then the factored form would just be this over here. All right, so just be on the lookout. It doesn't always have to factor, but you still have to factor that greatest common factor out. So it's fully factored. Okay, so, but this remaining bracket was able to factor into those two brackets right there. Okay, so with all of these, as usual, as I've been saying, look for greatest common factors you could take out. And then from there, once you take out greatest common factor, see if you could factor whatever is remaining.